We can use truth tables not only to classify or categorize statements, but also to compare statements. When we compare statements, what we're looking to reveal are logical relationships that may or may not exist among all of the statements in some group of statements. Okay, so take these two statements. Statement number one, if you work hard, then you'll succeed. Statement number two, if you don't succeed, then you didn't work hard. Okay? Now, to compare these statements, we're going to ask ourselves three questions. Question number one is this. Do these statements mean the same thing? Are these just two different expressions of the same idea, and these statements are kind of interchangeable with one another? Question number two. Is it possible for these statements to be true at the same time? At any given time, is it possible for both of these statements to be true? And finally, question number three, or is it impossible for these statements to be true at the same time? Okay, so comparing statements using truth tables to address these questions is going to be really valuable for us when we're trying to evaluate somebody's expressed belief system. Somebody comes forward and they say, hey, let me tell you what I believe. And they start offering to us a series of statements. We can test the coherency of that belief system by comparing the statements that comprise the belief system with truth tables to see, is it even possible for all of the things that make up your belief system to be true at the same time? Okay? Now, to compare these two statements, what we're going to do is we're going to create a truth table for each one. Using W to represent the statement you work hard and S to represent the statement you'll succeed. We have the truth table for statement number one looking like this. If you work hard, then you'll succeed. And the truth table for statement number two looking like this. If you don't succeed, then you didn't work hard. Okay, now to compare these two statements to one another, we're going to look at the column of truth values underneath their main operators. And we're looking to find a pattern. Okay, is there a pattern here? So when you look at the column under the two horseshoes here, do you see a pattern? I do. The pattern I see is that their truth values on each line match exactly. On line 2, both of these statements are false. But on lines 1, 3, and 4, they're both true. And that reveals that these two statements are logically equivalent statements. When one is true, the other's true. When one is false, the other's false. Okay? These statements make sense. They also, because they're logically equivalent and have the exact same simple statements as their components, they mean the same thing. Okay, these two statements mean the exact same thing. Now, I want you to take note of something. Literally, write this down. It's a super important point. Remember when we're comparing statements using truth tables that each line on the truth tables represents a very particular moment in time. So line number 1 on this truth table is the same moment in time as line number 1 on this truth table, and the same is said for lines 2, 3, and 4. Okay, that means that when I'm creating my second or third or fourth truth table, and that truth table has a letter in it that appeared in a previous truth table, those truth values have to match exactly. So when I created this as my first truth table, you can see that my values under W are exactly half true and half false, and I have alternating true and falses under my S. If I had started over from the very beginning using L equals 2 to the n to create this truth table, then my S term here would have had two T's followed by two F's. But then I'd have a conflict, because if lines 1 and 2 and 3 and 4 mean the same moment in time on this truth table as this truth table, then I'm going to have S having two different truth values at the same time, and that can't be. So when I go to create successive truth tables, I'm always going to be keeping my eye out for any letters in those truth tables that I've already assigned truth values to in a previous truth table. So here, I assigned the truth values for S in this manner, and so I have to do the same thing here under S here. Same thing with W. I assigned W these truth values, so it's got to have these same truth values over here. Okay, super important point. I see folks making mistakes a lot when they neglect that, and they just keep recreating truth tables for successive statements over and over, and then they've got some number of simple propositions that have competing truth values or conflicting truth values. All right, now take a look at this statement. This is a statement made by Joy to Jerry. If you don't love me, then I'm certainly not going to have sex with you. Now here comes Jerry's clever response. Aha. Well, that means that if I do love you, then you will have sex with me, right? Okay? So Jerry's repeating back to Joy what he or she claims to have heard, and is saying, I think this means the same thing as what you said, right? Well, let's create the truth tables to find out. When we use L to represent Jerry loves Joy and S to represent the statement Joy will have sex with Jerry, and we translate Joy's statement, we get this. If you don't love me, then I'm not going to have sex with you. And then here's Jerry's response. Okay, that means that if I do love you, then you will have sex with me, right? Now to compare these two statements, again, we look at the column underneath the main operators, and the first thing we look for is, well, do these columns match exactly? And we can see that they don't. On line 2, the first statement is true, and on line 2, the second statement is false. On line 3, the first statement is false, and on line 3, the second statement is true. Okay, so these are not logically equivalent statements. These statements do not mean the same thing. But there might be another pattern. And the other pattern we might identify is by asking the second question. Is it possible for these two statements to be true at the same time? In other words, is there any line on their truth tables where they're both true? And the answer to that is, well, yeah. On line 1 and on line 4, they're both true. And that tells us, okay, even though these statements aren't logically equivalent and don't mean the same thing, they're not incoherent. It's possible for these two statements to be true at the same time, and that means that they're consistent statements, okay? So we have logically equivalent statements and we have consistent statements. Consistent statements, there's the possibility that the statements could be true at the same time. It just depends on how things are organized at that particular moment in time. All right, so logically equivalent, logically consistent.